One of the ways we can tell if a function is linear is by checking to see if it's in slope-intercept form. But just because an equation is not in slope-intercept form does not automatically mean that it isn't linear. There are other ways to write linear equations besides slope-intercept form. So how can we see if an equation that isn't written in slope-intercept form is also linear? Let's go ahead and investigate that and see if we can come up with a strategy. This problem says a square tile has a side length of x inches. The equation y equals x squared gives the area of the tile in square inches. Determine whether the relationship between x and y is linear and, if so, if it is proportional. So this last part, if so, if it is proportional, is important because one of the things that a relationship has to do to be proportional is that it has to go through the origin. But the other thing it has to do to be proportional is that it has to be linear. So if we discover that this relationship is not linear, it automatically is not going to be proportional. Okay, so our equation is y equals x squared. How can we tell whether or not this is a linear relationship? It's not in slope-intercept form, but as I said, just because it's not in that y equals mx plus b form does not automatically mean that it's not linear. Linear equations can be written in ways besides slope-intercept form. So what can we do? And as you can see, we're going to be graphing this because if the graph is a straight line, it's linear, and if the graph is not a straight line, it's not linear. So let's go ahead and graph it. And one of the ways that we can graph something when it's not in slope-intercept form for us is by choosing some values of x and substituting those values of x into the equation. So let's pick a handful of values here. Now, if I knew that the equation was linear, I could just pick two values, right? To draw a straight line, we just need 2 points, and I can connect those 2 points to get a straight line. I don't know if this one is linear or not, so I can't do just 2 points. If I only do 2 points, of course it's going to look linear. 2 points will always make a straight line. So I need more than 2 points to check and see if it's linear. I'm going to do, I think, 4 points. I think 4 points will be enough to tell me if it's linear or not. So I'm going to make a little table here, an x and a y table, and I'm going to choose 4 values of x. Now I can choose any values I want to. And if I can choose any values of x that I want to, I'm going to choose some small values. So let's just choose like 1, 2, 3, 4. Oh, 0 would have been a good one to choose too. I should have put 0 on there, but that's fine. We'll go with 1, 2, 3, 4. Okay, I can choose any values of x that I want. And now that I've chosen these values of x, let's just plug them in and see what y would be. So finding y is pretty easy because all we're going to do is take the value of x and square it. Okay, so if x is 1, then y is going to be 1 squared, x squared, and 1 times 1 is 1. So my first coordinate is going to be 1, 1. X is 1 and y is 1. Okay, let's look at the next one. X is 2, so y is going to be 2 squared. 2 times 2 is 4. So when x is 2, y is 4. My next x coordinate is 3, so y is going to be 3 squared. 3 times 3 is 9. So when x is 3, y is 9. Great. And then my last point, x is 4, so y is going to be 4 squared. When x is 4, y is 16. I could have chosen some negatives here too. That would have been a good idea, but this is fine. Negative numbers would have been all right too. Okay, so I've got 4 coordinates. Let's go ahead and graph these coordinates. So my first one is 1, 1, and then I've got 2, 4. So let's stop right here. If I just stopped and graphed these coordinates, obviously I would have a linear relationship because any 2 points will make a linear relationship. That's why we had to have more than two. All right, let's do 3, 9. And last will be 4, 16. So let's get our ruler and let's see if I can draw a straight line. And when I put my ruler on those first 2 points, you can see very clearly I cannot draw a straight line through these points. In fact, this is sort of a curved shape here. This is actually called a quadratic relationship, which is something that you'll study quite a bit when you get into Algebra 1. So this is quadratic. It is not linear. So what we would say as our answer here, the problem said determine if it's linear. It's not linear. And because it's not linear, it can't be proportional. Because one of the two things it has to be proportional, it's got to be linear. Proportional means linear and it goes through the origin. This one actually would go through the origin. If x was 0, y would also be 0 because 0 squared is 0. This one would go through 0, 0. So it meets one of the criteria to be proportional. It unfortunately does not meet the other one because it's not linear. So 50% of proportional, but that's not good enough. It's got to be 100%. So this is not linear and it's not proportional. It makes a curved shape, therefore cannot be a proportional or a linear relationship.